Hello, everyone. My name is Carl Lewis from Landing AI, responsible for partnerships. I'm delighted to be joined by Saman, CEO of Sorsys today. Today, we're going to discuss how advancements in AI and computer vision are reshaping the typical approach to automated inspection systems. As you can see, we have a machine here that we're going to demo later on. We're going to have an interactive session. If you have questions, feel free to put them in the chat. It is a working environment here. We'll keep the noise to a minimum, but hopefully everyone will get something out of today's session. So just a little bit of background and some context and to set the stage. Sorsys provides pre-engineered and customized automated inspection systems powered by Landing AI. So that would include automation of a wide range of critical components. So critical components that you would see in a braking system, as an example, or an aerospace component. Sorsys also specializes in integration, advanced AI, data analytics, machine learning, industrial IoT, and cloud connectivity. So it's great to have a machine like this, but really we're pushing the boundaries with Sorsys to have this machine connected to the cloud, so you can get further insights from the machine at a distance. So a little bit of context on Landing AI. Landing AI is a computer vision focused company. We have a software platform that makes computer vision super easy, which means that we lower the barrier of entry for AI projects to help users build, deploy, and manage computer vision solutions without writing any code. So we're all about empowerment. We're all about making things really easy, accelerating your application right from prototyping to deployment, which means that we have a range of flexible deployment options, which includes cloud endpoints. If you want to deploy at the edge or in a Docker container, we have that as well. And it also means that we can be easily integrated into existing system architectures, let's say in a factory where you want to integrate a machine like this. So really the partnership between Sorsys and Landing AI means that clients can now achieve remarkable accuracy compared to traditional approaches, really opening and unlocking the value where before it was really difficult to automate a really subjective application. So for customers and clients who want to do automated inspection of critical components, and it's a super subjective application, we can now unlock that value. So for the agenda today, we're going to be talking about why use computer vision. Why should I consider powering my machine with AI? We'll talk about a comparison between AI and the status quo, but also how we should get started with a project. What are the stepping stones to have a successful project? We also share some examples of some successful deployments and share some of the learnings and some of the examples with the audience here. We'll also take a look at industry-leading technology, what to look out for in the market, what kind of questions to ask, and how to make an impact quickly with automated inspection systems, and how to unlock that value. So please, if you have any questions, feel free to write them in the chat. As Adrian said, Grace is moderating the session. We'll try to answer as many questions as we can, but let's jump right in. So just before Saman talks more specifically about AI-powered machines like you see behind us here, we'll give a little bit of introduction, more of an introduction to Landing AI. So Landing AI has a computer vision platform that enables our clients to build and test computer vision projects in minutes. No need for complex programming or prior AI knowledge. You don't need to be an expert. You don't need to be a data scientist or machine learning expert. we constantly refer to data-centric AI, which means that we require fewer images to deliver accurate results faster. We have a label book, which means that we can drive consistency in landing lens, which enables our customers to align on clear definitions of their defect classes that Saman will show examples as well. We also have tools like mislabel detection, which enables our clients to identify poorly labeled images, and which means that you can get going with your application quickly. And as I said before, we have a range of flexible deployment options, cloud endpoints, edge deployments, and also Docker containers. And then also, we'll talk a little bit about the continuous improvement aspect. We can upload images, new images to Landing Lens to our browser, which means that we can retrain models quickly and easily. So we have that continuous learning aspect as well. And then finally, scalability. So scalability is really a key differentiator for Landing AI, especially when customers want to deploy solutions across multiple plants globally. They want to bring teams together and manage multiple projects. And we have that with our Landing Lens platform, where you can manage that centrally in one location. We have a standard workflow, and it reduces the adoption time. It's easy to get started. We have a whole bunch of education, a whole bunch of videos you can watch to get going really quickly. So just a little final slide to explain how Landing Lens works. So Landing Lens is the name of our software platform. So essentially, it means that a user can upload a data set of images, label bad images, press a train button, and predict and do inferencing really fast and really quickly. So no code needed. You can really go from rapid prototyping to deployment in a few easy steps. And I've seen applications created in minutes. So with that said, let's transition to Saman. And Saman is going to talk more about Sorsys and talk about some of the use cases, and we'll end with a live demo.
Thank you. Good morning in West Coast, and good afternoon in East Coast. Everyone, I'm Saman Sahraei. I'm the CEO of Sorsys Technology. It's a pleasure to be here today. I come from a background in mechanical engineering, which has been fundamental in shaping my approach towards industrial automation and innovation. I'd like to extend special thank you to Landing AI for accommodating this webinar and for providing us with this platform to share insight and knowledge. Collaborations like this are essential in driving forward the field of AI in industrial application, and we're thrilled to be part of this journey together. Today, we are here to discuss some exciting advancement in AI-powered quality inspection and how these technologies are revolutionizing manufacturing process across various industries. I look forward to an engaging and informative session with all of you. So here's a quick agenda. We'll start by introducing Sorsys, our journey, and our mission. Next, we dive into a real-world case study, which will showcase the practical application of our technology. Then we'll introduce our RT series inspection machines. We'll explore its features and capabilities. We'll then discuss the traditional approaches to inspection and their limitation. Then we'll highlight the difference between AI-based and conventional inspection methods. And get ready for an exciting live demonstration of our technology in action. And finally, we'll share some key results and successes we've achieved with our system. Welcome to Sorsys Technologies. We're based in Mississauga, Ontario, in Canada. And we're known for our top-notch machines that use AI to inspect products. But our expertise is broader. We also build custom machines for putting things together and robots that uses camera to see and work. Our special skill is in making machines that check products using cameras. These aren't just any machines. They are designed to meet specific needs of different industries like cars and medicines and food. What makes us stand out? We're all about using the latest technology. Think artificial intelligence, learning machines, and smart internet connected services. This means our machines aren't just fast and good at what they do. They are also super precise. We're more than a company that just makes machines. We're a partner you can trust. Our goal is to help businesses keep up and do well in a world where technology is always changing. Uh, Before we dive into specific of our RT series inspection machine, let's take a moment to understand why automated inspection machines are a game changer in manufacturing industries. Firstly, the enhanced accuracy and consistency these machines offer is unparalleled. Unlike manual inspection, where the risk of human error is always present, automated inspection ensures that each product is inspected with the exact same level of precision every single time. This consistency is crucial in maintaining high quality standards. Moreover, automated inspection significantly increases product speed. These machines work at a pace of that far surpass manual inspection, allowing for a higher throughput, which is vital in meeting increasing market demands. Another key benefit is cost efficiency. While there is an upfront investment in technology, in the long run, automated inspection reduces labor costs and minimizing waste by accurately detecting defects. This translates to substantial saving and a quicker return on investment. The ability to operate 24/7 is another significant advantage. These machines don't get tired or need breaks, enabling round the clock production and thus maximizing your manufacturing time. Automated machines are also offering excellent opportunities for data collection and analysis. They provide valuable insight to your manufacturing process, allowing for continuous quality control and process improvements. Lastly, their adaptability is a major plus. These machines can be easily programmed to cater a different product to inspection criteria, making them incredibly versatile and suitable for wide range of manufacturing needs. Now, keeping these benefits in mind, let's move to our RT inspection machine, the machine that you can see in our background here, to see how it embodies all these advantages to revolutionize quality inspection processes in manufacturing. Let's take a closer look at our RT series inspection machine, a true powerhouse in automated quality control. This isn't just an inspection tool, it's a comprehensive solution that ensures every part we produce meet the highest quality standard. Here's how it rolls. Parts are begin their journeys in a conveyor system, smoothly making their way to the heart of our machines, the glass die. This is not just any stage, it's where the magic happens. The glass dial is key to our comprehensive inspection process, allowing us to view and capture images of parts from every possible angle. As the part travel through the machine, they encounter multiple camera stations. These cameras are strategically positioned to provide 360-degree imaging, ensuring no defects goes unnoticed. And we're not just snapping pictures. These images are meticulously processed using advanced techniques to determine the quality of each part. Once the images are analyzed, the system decides if a part is up to mark or not. The part that passes the test, they send to their way to the packaging conveyor, ready to head out into the world. But the one that don't make the cut, they are not going to see the light of the day. Straight to the scrap bin they go. What this means for us and to our customer is reliability and the precision in every product. With the RT series, we're not just inspecting parts. We are ensuring that every component we produce is synonymous with quality and safety. In our line of work, that's not just important, it's everything. Let's talk about something as a case study. Let's talk about something that we all rely on, but rarely think about: the brake system in our vehicles. And specifically, I wanted to dive into a tiny yet crucial part of it, a component with a 2 mm fluid passage. Now, this passage might seem insignificant, but it's vital for safety. Imagine this. What if the passage is blocked? Or worse, what if it's bent or damaged during manufacturing? These aren't just hypothetical. These are real issues that happen more often than we'd like. And the consequences, they range from minor assembly headaches to major safety risks, which like leaks, which nobody wants. This is where our vision-based inspection come into play. It's like having a super detail-oriented inspector with X-ray eyes and a never-tiring attention span. This system can spot even the tiniest blockage, bend, or damage, something that might flip past the most diligent human inspectors. Think about it. Human error in inspecting these parts isn't just a small oversight. It could lead to a real life on the road catastrophe. We're talking about the difference between a normal drive to a grocery store and a potential brake failure. So that's why we are so passionate about what we do. It's not just about technology and innovation. It's about keeping everybody on the road safer. And that's a mission we take very seriously. Let's dive into the limitation on existing conventional inspection approach. This approach, while familiar, comes with its own set of challenges that can impact efficiency and accuracy. If you want to run that video, or full screen. At the first step is capturing the image. This seems straightforward, but it's crucial. The quality and clarity of the image directly affect the inspection outcome. However, the conventional method are often struggle with the consistency in image quality, especially in varying lighting condition or with parts that have complex geometry. After capturing the image, the system must ensure it's in the right position. This is done using a position compensation tool, which add on an extra layer of complexity. Any misalignment, no matter how small, can lead to an inaccurate inspection. Then we define an inspection area for each criteria. This requires precision setting and adjustment, especially if the parts are very slightly or have complex shapes. It is a time-consuming process that needs the expert knowledge and attention to details. Next, we often need and apply an additional filters to enhance the image. This requires precision setting and adjustment, especially if the parts vary slightly or have complex shapes. It is time-consuming process that needs expert knowledge and attention again. Finally, the most intricate part, setting an inspection tool for each defect and defining the thresholds. This stage is heavily reliant on technicians' expertise and can be quite subjective. The threshold set for one part may not applicable to another, leading to constant needs for adjustment and recalibration. In summary, while conventional inspection methods have served us well, they come with limitations that can impede efficiency, accuracy, and adaptability. With advancement in AI and automated inspection technology, we now have the opportunity to overcome these challenges, paving the way for more reliable and efficient inspection process. So while you're watching the video, this video shows how what the steps of setting up the conventional inspection. And so if we go to the next one. Okay, so let me go through this next slide. So this slide shows the architecture of how do we set our machine connected to AI software and hardware. Moving to the core of our AI-based vision inspection system, let's dive into the hardware architecture that empowers our application. This slide illustrates the seamless interaction between various high-tech components, ensuring that our inspection process are both accurate and efficient. As you can see, firstly, our GE camera by Bomber captures high-resolution images of products. Its precision is key to our system's ability to detect the smallest imperfection. These images are then swiftly relayed to a frame grabber, an Advantech PCLI device. The frame grabber's main task is to handle these high throughput data streams and feed into the processing with unit without delay. The landing lens works in tandem with our camera, refining the focus of each image to ensure that our AI algorithm have the clearest possible data to work with. Central to our hardware setup is the landing edge, equipped with an NVIDIA RTX A4000 and an Intel Core i9 CPU, backed by 64 GB of RAM. It's here that the magic happens. The landing edge executes our sophisticated AI algorithms, analyzing each image with remarkable speed and accuracy. The process data is often communicated to our controller, an Allen Bradley compact logic, via a secure Shield RJ45 cable. This controller interface directly with the PLC, translating the AI's decision into actable tasks. And finally, the inspection machine, the RT series in this case, responses to these commands, sorting and handling product based on insight provided by our AI. Each piece of the hardware is a vital link in this chain, working in harmony to create a system that's not just a collection of parts, but a unified whole, significantly enhancing the quality and reliability of our inspection process. And that brings us to an end of our look at architecture technology. We use it here at Sorsys. Now I'm excited to pass this stage over to Carl from Landing AI. Carl's going to take you through the incredible capability of Landing Lens cloud software, showing you exactly how it works and how you can create model with it. Carl, floor is yours, and I'm delighted to listen how you have them.
Sounds good. Thanks, Saman. I'm sure everybody's looking forward to seeing the machine demo. Before we get there, let me just take everyone through Landing Lens. So as I mentioned at the beginning of the presentation, Landing AI has a platform called Landing Lens, and here you can upload images, you can label, you can train models, and you can deploy. And in this case, we have a edge device in the model that was built using the Landing AI software, was deployed in the machine here. So just to give everyone a flavor for what's happening here, previously we had uploaded a lot of images already classified that you can see on the right-hand side. So we have, this is the brake line assembly. So we have classes like damaged stem, chips, bent shell, bent, and block stem. So we had uploaded quite a few images, and they're already being classified with these particular classes. And then we hit the train button. So as you can see here, we've correctly classified and predicted these different images. So if I click on one of the images and look at this one particular, this is a bent shell. So you can see here with the heat map that I've enabled, it gives graphical representation of the individual pixels that were activated by the model. So this gives a really good graphical representation of which part of the part is defective. So this is bent. You can see here that in the middle, those pixels were activated by the model. So, as we're building the application, it could be that the customer, realizes that additional classes, so we can add additional classes to our application. We can continue to label images. We can continue to train. We continue to refine. And in this case, we've got a really good accuracy result with our precision and recall. And the next step after this, and when we're happy with the performance of the model, is to deploy. So now what I'd like to do is pass it to Saman, who's going to talk about the machine, and is going to talk about how it's integrated into the machine, and we're going to do a little bit of an interactive demo.
Yeah, thank you, Carl. So my colleague will be, running the machine for a few minutes. Then we'll discuss a few decision. We're going to discuss a decision matrix there. We're going to compare the use of conventional vision system and landing AI in this case. So so I want to ask my colleague to run the machine. If you can, Sina, can you start running? So as you can see, we have this the feeding conveyor that is either by any feeder or robotic feeder or conventional vibratory feeder. We can feed the machine. The parts are traveling through that feeder, end up on the glass tile. They're passing through the camera stage. We're going to take different angles, different pictures, and then while the parts are passing, then we have good parts and bad part. The good part will be ending up the shoot discharge conveyor going to the packaging, and the bad part end up on a recycle bin. So in this cycle, so the camera, the monitor that you see here, this is a live image of what landing AI are making decision. Basically the landing edge in this case, while the model is deployed. So it's making decision whether it's a good part or bad part, and it's showing us which area is the problem that the AI thinks that it's a bad part, or the reference of the decision is what is that. So so we're gonna have a little bit of noise there, but I guess we're okay. So I want to talk about some differences between conventional inspection system and the modern AI-based inspection, like the one offered by a Landing Lens from Landing AI. Let's break it down feature by feature. First, let's talk about the required skill set. With conventional system, there is a significant learning curve demanding a high skill set from operators. In contrast, AI-based systems like landing lens are designed with user friendliness in mind, requiring a much slower skill set. This means more accessibility and less training time. Now, vision setup time. Interestingly, both systems have similar setup time initially. This might come as a surprise, but it's important to note that the ongoing adjustment and maintenance time differ significantly, as we'll see. When it comes to system costs, including the camera, software, lighting, conventional system usually comes with a higher price tag. In contrast, AI-based systems like landing lens are generally more cost-effective, not just in terms of initial setup, but also in long-term maintenance and scalability. Setup time is another, software setup time is a critical factor. Traditional systems required a substantial amount of time to get up and running, especially when dealing with the new products or changes in production. AI-based system, however, boasts a significantly lower setup time, offering greater flexibility and efficiency. User experience is paramount. A conventional system can be complex and challenging to operate, whereas AI-based systems are designed for ease of use, ensuring a smoother, more intuitive experience. Supporting protocols for both systems remain consistent, ensuring that they can be integrated into existing production process without major disruption. Hardware flexibility is a game changer. Traditional systems often lock you into specific hardware configuration, limiting adaptability. AI-based systems, on the other hand, offer high hardware flexibility, accommodating a range of cameras and lighting setups. Lastly, custom adjustment. Conventional system requires frequent and often complex adjustment, whereas AI-based systems, thanks to their learning algorithms, needs fewer manual tweaks. In summary, the shift from traditional to AI-based inspection system represents a leap forward in efficiency, cost effectiveness, and ease of use. It's not just about keeping up with technology. It's about embracing a solution that transforms a quality inspection process into a smarter, more adaptable, and user-friendly experience. Let's move to the next one. As we wrap up, I'd like to highlight the key benefits of AI in automated inspection, which are transforming the manufacturing landscapes. Our platform is designed to be intuitive, allowing your team effortlessly create solution. Our model ensures high data quality and reduces error, providing effective even with a smaller database. A significant challenge in automotive inspection application is the subjectivity involved. Our AI solution excels in these scenarios by providing consistent objective analysis, removing human error and bias. With cloud and edge device deployment options, integration into existing setup is straightforward. Whether it's a single line or global operation, landing lens makes scaling your projects simple. To bring these benefits to life, let me share a quick story. We had a customer initially hesitant to implement an automated inspection system, worried about the skill set required for running such advanced machinery. With AI-powered solution, this concern was eliminated. The case of setting up new parts and the ease of setting up new parts and adjusting inspection criteria meant that their team could quickly adapt without needing specialized training. This not only streamlined their production but also boost their confidence in embracing AI technology. This story is just one example of how AI is not just a tool, but a partner in innovation, making advanced technology accessible and beneficial for all. That's for me. Thanks for joining us today, and we look forward for empowering your manufacturing journey with AI. Handing over to you.
Thanks, Saman. I think, Grace, we're going to take some questions.
Yeah, sounds good. Thank you, Carl and Saman, for the session today. It was very insightful and informative. Now we are moving into Q&A. I see some folks already asked some questions via webinar chat as well as Q&A. So if you do have any question, please feel free to add a Q&A chat in the chat function in the Zoom. Yes, I have one question from Hossein. Could you please explain 360-degree inspection as items are on the flat conveyor and one side of item is out of camera side, but it is a transparent conveyor. So I don't know if Saman, do you have any experience on the 360 inspection and share some insight?
Yeah, as I explained, we are not inspecting on the conveyor. We are inspecting on a glass dial, while the conveyor is, transferring parts from the feeding side to the glass dial. While the parts are landed on the glass dial, then we have access to every angle of the parts if needed. Plus, we have different stations for the cameras mounting, so we can mount the cameras any angle, even underneath. We have exposure underneath the part if needed. So that's how we claim that it's 360-degree imaging stage.
Thank you. Yeah, and following question maybe related to that. Could you share some advice when it comes to choosing hardware? What hardware should I use when I build a computer vision solution? I don't know if Carl, you want to.
I can take that. Yeah. So one of the great advantages of Landing AI is that we're hardware agnostic, which means that you can mix and match the hardware depending on the application. So just thinking about an inspection application, just thinking about this brake line inspection, for example, you can see on the screen here and looking for really subtle defects. Best practice, we recommend at least 10 pixels across the size of the smallest defect that you're attempting to find, or 10 pixels across the size of the smallest object. And that is based on the camera's field of view, the number of pixels across it. So there's some math involved to select the specific camera. There's also, the speed of the application. We want to make sure we take enough images of the object as it moves in front of the camera. Then it's all about processing the data, and Saman talked about the edge device that he has here in the machine. So it's really understanding, the application, its constraints, and then can be engineered around, what you're hoping to achieve. But it can also grow. So if you're looking to run faster in the future, the solution can be engineered according to that as well, not just what you would like to do at that moment in time.
Thank you, Carl. And how fast can my machine inspect part? I don't know if Saman, you want to take this one?
Yeah, I'll take that. So it's all, depends on the how accurate and then what kind of resolution are we, looking at. But normally, and the other limitation is the feeding system. So with the regular, application that we have currently, the machine can run 60 parts per minute. Every 1 second we can run it. That's with 6 cameras in the machine and like a 5-megapixel camera. We can run the machine 60 parts per minute.
Great. Thank you. Next question is, how do I start my application? Do you have some advice how I can get started?
You mean for the inspection machine or the landing lens?
So I think it's building a computer vision solutions as a user who wanted to start for the first time. What are the approach you would recommend?
I would say it's all about the field of view. So what size of the part, and then the size of the part, and then the smallest size of defect that we want to deal with it. That's our design. And then the surface, the part surface, how shiny the part is, what's the background, and all these things. So this answer to this question will have a design of the vision system. What kind of camera, what resolution, what kind of lighting, and can we take a picture while the part is moving, like what we have here, or should we stop the part, take a picture, and let it go? These are all questions that needs to be answered before we design a vision system. Then on the software side, we're gonna see what kind of defect are we talking about, then what kind of tool required. Either we're gonna use the conventional vision system or AI based. If it's AI, then it's easier. So then we just, run known good parts and known bad parts, deploy it to the software, we'll create a model, deploy it back to the landing edge software, and then we'll go from there. It really depends on the application.
Sounds good. Anything wanted to add, Carl?
Yeah, so as Saman said, once the hardware has been selected and the image set has been created, like I showed earlier, uploading the images to Landing Lens and labeling and pressing that train button, it typically takes a few minutes to create that model. Once that model is created, it can then be deployed with Landing Edge, which is the name of our software app. And that is typically done, in minutes. Previously, with other approaches, it could take days, to deploy an application, or perhaps weeks. So we're really accelerating the adoption and solving new problems.
That's good. Thank you. And with that, I think we can conclude our webinar today. Thank you, everyone, to joining today's session. And as we have the Q&A slide here, please feel free to visit sorsys.ca to learn about Sorsys solution and services. And if you want to start building your computer vision model, visit landing.ai, start free trial today. And follow us on the social media to learn about more upcoming events. Thank you, everyone, and Carl and Saman.
Thank you.
Thank you, everyone.
Take care.